Okay. Yes, very good evening, everyone. Good evening, Harshita, Shruti. Good evening, bache. So, in the last class, we revised mole formulas, right? We have seen 3 formulas of mole, and we have seen their questions also, how they can ask questions, right? More practice we will do later on. Good evening, Chandana. Okay, fine. So now today we are starting our next topic, stoichiometric calculations. Like I said, mole concept is very important, and mole formulas will be used in many topics. So in stoichiometry calculations also you see the mole formulas will be used again. Okay. So let us start then without wasting time. So the topic is stoichiometry calculations. Okay, bacha? Okay, fine. So we will move step by step. Like first we will take some simple questions, then we will move step by step with limiting reactant and then percentage purity and percentage yield type of questions. Okay. So first of all, to do the question of stoichiometry or stoichiometry, whatever you want to say, we have to move in 3 steps. First of all, write a balanced equation. Whenever they give some question on this, write a balanced equation of the given reaction. Right? I'm saying how many steps it will take. So first of all, you have to balance the equation. Okay? Second thing is write molar ratio, or I will say write the molar coefficients of all the constants. Right? So main thing is we have to balance the equation. If you are having unbalanced equation, then definitely you can't get the right answer. And third thing, we have to use this one. We know what is mole. From mole we can get what? We can get volume easily. Sometime we can get weight, or you can say mass, or maybe sometime number of molecules or atoms or ions or whatever we want, right? This we have seen in the last lecture, so we'll use it in our upcoming questions. Okay, bacha? Right? So our main thing is you have to balance the equation, and then we have to use this 3 formulas of mole to solve our questions. Okay, bacha? Like what a balanced equation tells us. Example I'm telling you. Imagine I'm writing here the simplest question. I'm saying N2 3H2, and it is reacting and giving us 2 of ammonia. This equation is given here, the most common equation in the stoichiometric questions. Fine, bacha. Now it is balanced. So you have to write this, that the stoichiometry ratio is what? It is telling you that when 1 mole of N2 react with 3 mole of H2, I'm writing mole here. This equation represents that when 1 mole of N2 will react with 3 moles of H2, it will make what? It will make 2 moles of ammonia. It will make 2 moles of ammonia. So this thing we have to understand. Definitely I can say that when 1 mole of N2 will react with 3 molecules, okay, I'll say 1 molecule of N2 react with 3 molecule of H2 will produce 2 molecule of ammonia. But always think in terms of moles. Okay, whenever I have this balanced equation, so always think that 1 mole N2 is reacting with 3 mole H2 and giving me 2 moles of ammonia. That's it. Are we clear about it? Okay, let us see a simple question. No, beta, no, this chapter is not tough. Just you have to follow all the instructions given to you. In every topic, we will move step by step. And the main cause why we are starting with this topic, because it will help you whenever you will join the long-term course. These same things will come again, so that it will be clarified in your mind very easily, right? Okay, Fine, bacha. We'll discuss all these things. We will discuss all these things. Okay. Let us see again. Here, how they can ask you questions on this basis. Imagine from the above equation I am writing here N2, 3H2, and here we have 2 ammonia. Right? Stoichiometry is very much clear. It's telling me that 1 mole N2 give me I need 3 mole H2 and produce what? 2 mole ammonia. Fine? Clear, bacha? So the question is, this time I'm asking very simple question. I'm asking a question. What is the question? Question is, imagine I am having 5 mole of N2. Imagine in the question they are saying, if I have 5 mole of N2, then to completely finish 5 mole of N2, I will need how many mole of H2, and the 5 mole of N2 can produce how many mole of ammonia? Can you answer me very simple question? The starting basic question I'm asking. They will write the same question in terms of like they will give in verbal form, written form. They will say 5 mole of N2 if I'm having, so how many moles of H2 will be required to completely react with the N2, and it can produce how many moles of ammonia? Please answer me fast. Answer me fast. Harshita, right, beta? Good. Just unitary method I have to apply. Everyone, we have to apply unitary method. Good, bache, right? Harshita, Lakshmi gave the right answer. Fine, fast, everyone. Okay, so you can see very easily, all of you are giving good answers. 1 mole of N2 need 3 mole H2, right? So 5 mole will need how many beta? 1 need 3. So 5 need how much? 15. Right? 1 mole N2 produce 2 mole ammonia. So 5 mole N2 can produce how many? 10 mole ammonia. Can produce 10 mole ammonia. Right? Okay? Chandana, right, beta? Okay. Everyone is giving right answer only. Fine. Okay. Now imagine question they asked little bit changed. I am saying here, now this is the question. It is second question, okay? Different question they will write. This time they are saying, if I am having here, if I am having, imagine, we are having 18 moles. I am having 18 moles of H2. So how many moles of N2 are required? If I am having 18 moles of H2, then how many moles of N2 are required for this to consume the complete H2? And how many moles of ammonia can be formed from here? Yes, everyone? The simplest type of question they can ask from here, stoichiometry. Ask me fast. Okay. Chandana is saying, Harshita saying 6. Fine, bacha, fine. Right. Just apply the unitary method. Harshita gave the right answer. Lakshmi, NS. Okay, beta. Fine. Good, bache. You see here, what we are having? 3 moles H2 need how many moles of N2? 1 mole. So 18 moles we need how many more, beta? 3 need 1. So 18 need how many? 6. Clear? Very good. Fine. 3 moles H2 can produce 2 mole ammonia. 3 mole H2 can produce 2 mole ammonia. 18 moles will produce how many? 12 moles. Okay? If you can't write it directly, sometimes we can have problems, or we can't think that much directly. So apply unitary method. How I am doing this? Look at this carefully. Do the unitary method, right, beta? So look at this here. 3 moles H2 produce 2 mole ammonia. Go by unitary method. 1 mole H2 will produce how many? 2 by 3 mole of ammonia. Right? So if I take here how many beta? 18 moles, right? If I have 18 mole H2, then how many? 2 by 3 into 18 moles of ammonia. So how much coming from here? 12, na? Just unitary method. Apply unitary method here. Okay, if you can't think it directly. But I am saying here again, look at it, look carefully. Like I said here, 1 need 3. So 5 need how much? 15. Similarly, 18, 3 needs 1. So 18 is how much? 6. Unitary method. I hope we are clear about this. Right? Okay, I'm taking the next question, beta. I'm taking the next question. Remember, I gave you balanced equation here. If they don't give you balanced equation, first balance it and then think about it. Fine, bacha? Okay. Look at this. Imagine I am taking some more equation. I am burning, or we are doing combustion of methane. CH4O2, give me CO2S2. First of all, balance it. Balance it by yourself. Write the stoichiometric ratio by yourself, the molar ratio. And then what I am giving here, I am giving, imagine if I took 8 moles of methane, so I need how many moles of O2? It will produce how many moles of CO2 and how many moles of S2? Is it better? Okay, clear. First of all, balance it. Without balancing, you can't start the question. In this question, I am giving you reaction. Sometimes they don't give reaction, so you have to write the equation by yourself and then you have to balance it also. Make it fast. Let's make it fast. Right, bache? Okay. Shakeen. Good bacha. Right. Okay, so what do we have? First of all, balance it. The first need is to balance the equation. Okay, bacha, you're balancing it. What is it? 1 mole of CH4, if you balance this one, so here the 1 carbon, okay? To balance, I need how many hydrogen? 4 hydrogen. Here how many? Only 2. So I will take 2 here. Right? Okay, bacha? Here I need 2. And now, to balance oxygen, how many oxygen? 2 oxygen here, 2 oxygen here. How many? Only 2. So I will balance it by taking 2 here, right? Now is it a balanced equation? Yes. Now every element is balanced in the equation, right? We are balancing it by the hit and trial method. Okay? Simple one. So from here I can say the stoichiometry is telling us that it's 1 mole. Methane need how many mole here, beta? 2 mole O2 will make 1 mole CO2 and will make what? 2 mole water. This stoichiometry ratio is very much important for us. Okay? The next part, we can see clearly 1 mole need 2 mole of O2. So 8 mole need how many, beta? 16 mole, right? 8 mole need 16 mole. Very good. Now you can see 1 mole produce 1 mole. So 8 mole produce how many? 8 mole. Good. And now 1 mole produce 2 moles. So 8 mole will produce how many mole? 16 mole. So they are giving us, very good, Monica, Chandana, Lakshmi, everyone gave the right answer. Good. Okay? They are giving us one thing and they are asking the remaining things. So just using the stoichiometry, simple unitary method, you can answer. Okay? Next one I am asking. Imagine this is given. Imagine they are saying we want to produce here, but imagine we want to produce 7 moles of CO2. I want to produce 7 moles of CO2. Tell me, move step by step. I want to produce 7 mole of CO2. So how many mole methane required, how many mole O2 required, and how many moles of H2O will be produced with this? Yes, everyone, fast. Here I am giving the equation, I am balancing it, but sometimes they don't give the reaction also. So you have to write the reaction by yourself. I will give this type of question also. Don't worry. Just simple stoichiometry we have to apply, right? Okay. Yes, Harshita, Shakeen. Good. Very good. Okay. Look, Bacha, look what we have here. Tell me, if you look here, 1 mole CO2 production need 1 mole CH4. So 7 mole CO2 need how many moles beta here? 7 moles. Fine. Right? 1 mole needs how many moles? 2 moles. 7 moles need how many moles of this? 14 moles. Clear? Good. And when its 1 mole will be produced, its 2 moles will be produced, right? So its 7 mole production will also produce 14 mole of H2O. Will produce 14 mole of H2O. Fine? Right, everyone? Good? Okay. Just unitary method. Now, one more I'm asking. Same type only, same question. Okay? So imagine they are giving us, they're saying, here I am having, imagine 5 moles. I have 5 moles of O2. I have 5 moles of O2. I need how many moles of CH4 to completely consume 5 moles of O2? It will produce how much CO2 and how much H2? First, just for practice, I am giving you small questions. Then weight will come, volume will come. So many type of question will come step by step. Okay. So please answer me fast. If I have 5 mole of O2, to completely consume 5 mole of O2, I will need how many mole of CH4? It will produce how many mole of CO2 and H2O. Fine. Is better. Fast. Yes. This time it will come in. This time it will come in points or fraction. Okay, possible, no issue, not a big deal. Fine, beta. What is that giving? Look at this carefully. 2 moles. 2 moles need 1 mole. So 5 moles will need with how many moles? 2.5 moles, right? Just unitary method. 2 needs 1. So 1 need 1 by 2. 5 need what? 1 by 2 into 5. Right? Here 2 produce 1. So 5 produce how many? 2.5. Right? And this time if you see 2 moles of this give 2 moles of water. So 5 moles will give how many moles here? 5 moles. That's it. Great. Done everyone? Done everyone? Okay. So I am giving the next question in form of like statement. I'm not writing the equation. You have to write the equation. Okay? Okay, bache, fine. Now, easy question. Find how much volume. Find how much volume of CO2 gas at NTP, okay, can be produced by heating how much? I'm saying imagine 250 gram of CaCO3. 250 gram of CaCO3. Now, this type of question are very, like you can say, very frequently they ask. Easy question. But in the question, first step is reaction not given. So you have to write the equation. Okay? Definitely in the paper, they will not give this type. They will not make blank, filling the blank type of question. They will give a statement. So from this, you have to come to this type of, like this way. Imagine I am writing here. Equation is very clear. They are saying CaCO3 is giving us what? CaO and CO2. Right? Right, bacha? This is the equation. Very common equation. Many times you will see in the syllabus. Okay? Now write the stoichiometry ratio. Stoichiometry ratio is telling us that after balancing, it is already balanced. If you see, it is telling me that 1 mole CaCO3 give me 1 mole of CaO and give me 1 mole of what? CO2. Very clear from the given statement, right? Now, if you see carefully, what they gave to us, beta, if you see carefully, what they have given to us, if I say given thing, have they given us moles or they give us weight, beta? What they have given us? They are saying us we are having 250 gram. We are having 250 gram of CaCO3. Is it weight? Is it weight, or is it weight, or this is your moles? This is weight. So first of all, convert weight into moles, because this question is a little mixed. They gave weight, they're asking volume. So first of all, we have to find the molar ratio. We have to find the molar ratio. Yes, beta. So look at this carefully. They gave me 250 gram. They gave me 250 gram of CaCO3. Can I make it mole? Can we make it mole? Yes, we can find out the moles of CaCO3. How? We can find by the given weight divided by its what? Divided by its molar weight. That means 100. So how many moles coming? 2.5 moles. So if by chance they gave me weight, so from weight find the moles. How we find the moles? Given weight by molar weight. CaCO3 have molar weight of how much? 100. So how much coming? 2.5 coming? Very good, beta. So from here I have 2.5 moles. I have 2.5 moles. We can see clearly, right? Now apply our simple stoichiometry. Now I know that it's 1 mole. Give me how many moles? 1 mole. So it's 2.5 mole will give me it's also 2.5 mole, right? And it's also how many moles? 2.5 moles. Okay, but in the question, are they asking me moles of CO2 or they asking me volume of CO2? I got the molar ratio. I know molar ratio. 1, 1, 1. If I took 2.5, it gave me 2.5, 2.5. Right? Now, but they're asking me volume. So I will convert this moles into volume very easily. How, beta? How you can make volume? Volume is what? Number of mole into 22.4. So we have here 2.5 liter. So 2.5 mole into 22.4. Very good. Right answer we gave. It's very great. 2.5 into 22.4. How much coming? Give me answer. 2.5 into 22.4. How much coming? Yes, let us Shruti give the right answer. How much? 56 liter. Fine, bacha. Very good. Harshit also give right answer only. Many of you give right answer. Shruti, Siddhakar, Lakshmi. Hello, bacha. Good. I am showing you step by step. In the paper, we will not spend so much time. But I want you to understand the logic behind it. If they gave a little bit twisted question, so that you can understand it. After practice, you will solve this in 5-10 seconds maximum. Okay? Done? Now I am taking the next question. Same question. Okay? Same way. So please answer carefully. Okay. Now the next one is, look at this. Question is how many? Okay, I am giving same question, right? How much volume? How much volume of O2 gas at NTP will be required for complete combustion? Complete combustion of I'm saying here 90 gram of ethane, right? It's where 90 gram of ethane. Okay. So again, combustion reactions are very, very important. All the time they ask questions from combustion reactions. So I'm writing reaction for you. Ethane, beta, ethane means what? C2H6. Ethane. Ethane we are burning with O2, and hydrocarbons on combustion always produce a fixed thing, CO2 and S2. So easy to get the answer. Please balance it. See carefully what they're asking. They gave one thing, they're asking other thing. They are giving one thing, they're asking other thing, right? Fast, fast. Can you balance it? Can you balance this one? First balance it. From the weight, better. From the weight, find the mole, mole, and then they're asking volume, so find what? Volume from the moles. Fast, make it fast. Yes, बच्चे. Okay. So if you balance it, what is coming? C2 here, how many carbons here? One only, I will balance, make it 2. Right? Hydrogen, how many? 6 beta here, here only 2. So I am making it 3. 6 hydrogen, 2 carbon. Now balance beta what? Oxygen. How much oxygen here? How much oxygen? 2 into 4. 4 and 3, 7. So 7 oxygen is coming here, so I will take 7 by 2. 7 by 2, right? It is our balance equation. If I balance it, the stoichiometry coming how much? It's 1 mole. If you look at this beta, what is coming? 7 by 2 moles. So I can say how much? 3.5 moles. Or you can say 7 by 2, no issue. Produce its 2 moles and produce how many moles? 3 moles, right? This is a molar stoichiometry or molar ratio. Remember steps. Write the balance equation, write the stoichiometry ratio or molar ratio. Right? Good, bache. We'll check same answer coming or something different. Okay? Now, in the given question, have they given us moles directly? Are they giving us moles? No. They're asking us weight, 90 gram methane. Can you find the moles? Yes, beta, we can find the moles. How we can find the moles? They gave me 90 gram. 90 divided by how much? 30. So how many moles coming? 3 moles coming. 3 moles coming, right? That means indirectly they are giving me 3 moles of ethane. So with 3 moles of ethane, I had to find how much oxygen required. Right? 1 mole need 3.5. Now apply unitary method. 1 mole need 3.5 mole. So 3 mole need how much? Unitary method. 3 into 3.5 mole. That is how much, beta? If you solve, how much coming? 10.5 moles. So 10.5 moles of O2 are required. 10.5 moles of O2 are required, right? Yes, beta. Shakin, get the right answer. But in the question they're asking me volume. So I can make it volume. How? Volume, so we know that moles into 22.4, right? So how much coming from here? Is everyone saying same answer? So I hope this is right only. What is coming? So 235.2, right? I hope this is coming. 235.2 liter, fine? Okay, bache. Great. Fine. These are the simplest questions. When they give one thing, they ask other thing. Nothing limiting reactant required here, nothing else. Just they gave one thing, they ask other thing. That's it. I hope we are clear about it. Right? Okay, one last simple question, then I will come to the topic limiting reactant. Okay? Little change will come. On this basis, simple basis, I am giving one more question. Okay? Then bache, same question I am asking. Question is find weight of MgO that can be produced. Find the weight of MgO that can be produced by hitting beta, you can say 16.4 gram of MgCO3. Okay, I will heat MgCO3. Okay, or just let me clear. Chandana beta, equations will come in your syllabus. So many equations will come, right? If you remember those equations, then only we can understand which equation to use in which question. And actually, there are some fixed equations all the time, which will come again, like formation of ammonia, heating of CaCO3, combustion of ethane, methane, propane. These equations are very common. They always ask same question. Right? Right. Okay. Okay, bacha. I'm telling you once again. There are some fixed questions all the time. There are max to max 10 or 12 equations which we will use in our questions again. And the same equations will come in your syllabus or in your paper of NEET exam also. In the NEET exam, always they ask this equation: N2 give 3H2 and ammonia. CaCO3 give you Ca or CO2. So these are fixed equations. Don't worry, they will not ask any random equation which we have not seen. It will come from your module only or notebook only or NCERT, the common equation which we are using in every class or every time. Okay, don't worry about it. This is our problem. We will clarify that part. Okay, bacha? Okay, this is the question. Now, if you don't know the equation, let me help you. If we heat the magnesium carbonate, it give me magnesium oxide and CO2, right? Similar to like CaCO3, that's it. Now think about it. Now you have to solve. Like now you have seen this equation. Shruti or Chandana beta, now you have seen the equation. Now you have to remember it. For the further questions. If by chance the same question or same equation comes, now you have to remember it. Okay? So, stoichiometry very much clearly balanced beta. I can see stoichiometry. It is telling 1 mole, 1 mole, 1 mole. Right? Okay. Now, are they giving us moles or weight? I can solve this question directly in weight also, but it is more easy to go in moles. So, what are they giving me? They are giving me 16.4 gram. 16.4 gram they gave. I want to find mole. How I can divide? I will divide by 84. If you see its molar mass, beta, how much molar mass? Mg is how much? 24. Carbon how much? 12. 16 into 3, 48, right? So its molar mass is 84. So 84 is the molar mass. We apply the formula. What's coming, bacha? It's coming, sorry, I gave you how much? 16.4. Let me make it easy for you. I am making it 16.8. Whatever they gave you, you have to use that only. Whatever they gave you, you have to use it. But to make the question easy, I am making it little change. I am taking 16.8 so that you can solve more easily. And how much coming from here? 0.2 moles. Yes, otherwise it's coming 0.195. Okay, beta. Okay. So 0.2 is coming, imagine. So now I know variable that 1 mole produce 1 mole. So 0.2 mole produce how many moles? 0.2 mole. But in the question, are they asking me weight or they asking me moles? They asking me weight. How I can get the weight? Mole into what? Molar mass. What is molar mass? MgO. 24 plus 16, 40. Right? So 40 is coming. And here how many moles are there? 0.2 moles. So 0.2 moles into 40 give me how much? 8 gram. Is it right? You give right answer only, most of you. Good. I hope we are clear about these questions. Right, bacha? If by chance they give you weight, they ask you volume. So convert into moles, get mole to mole, molar ratio, and again convert back from mole to volume or mole to weight, whatever you want. Okay, bache? Now I'm taking the topic of a limiting reactant. Okay. In the limiting reactant topic, they will give you 2-3 reactants. Then you have to check which one is limiting, and then we have to proceed the question. In this question, they gave me only one thing and they asked me other thing, right? So there was not a need to check what is limiting reactant or not. Okay, good. We are clear. Okay, let us see the next part. In this topic only, we are moving step by step to other points like limiting reactant, you can say, or limiting reagent, you can say. It's fine. Okay. So I'll say here, what is it? It is a reactant which will finish first. Reactant, out of it are 2 or 3 reactants. So reactant which will finish first and stop the reaction. Right? So you can say that limiting reagent is that reactant which will finish first and stop the reaction. Okay? Or sometimes they say, I'm writing different definition. You can see in your books NCERT also. Reactant which will be present in less amount according to stoichiometry. Okay. Now here students make mistakes. Sometimes they ask question. Sometimes they ask question like statement type of question where students make mistake. Be careful about this definition. If they give me this definition, they say reactant which will be present or which is present in less amount. If they give me the definition up to here, this will be wrong. This will be wrong. We have to write completely the reactant which is present in less amount according to what? Stoichiometry. According to stoichiometry. Otherwise, this will not be clear. Right? That reactant which is present in less amount according to stoichiometry is limited reactant, right? I will tell you by taking examples, don't worry about it. If someone just write this definition, which is present in less amount, it is wrong. You can't say it is the right definition. You have to say which is present in less amount according to stoichiometry. Okay? I will give you example, don't worry. To explain this point, I will give you examples, don't worry, okay? Or the main thing is limiting reactant or limiting with a reagent, you can say limiting reactant will decide the amount of product formed. This is very, very important. Okay? So who will decide how much product will form beta? The limiting reactant. Excess reactant is that reactant which is present in large amount according to stoichiometry. So who will decide the product of you can say amount of product? The limiting reactant. Okay? We'll discuss about it step by step, don't worry. Okay? So be clear about these 2-3 points. First of all, I am taking 1 or 2 example here, small example. Okay? Look at this. I am taking here the most simplest equation here, N2 3s2 is giving 2 ammonia. Fine. Now stoichiometry clearly telling us that 1 mole of N2 react with 3 mole of H2 and produce 2 mole ammonia. Stoichiometry we have seen already, many questions we have seen. 1 mole N2 need 3 mole H2 need 2 mole ammonia, right? Now imagine initially in such type of questions I will write T0. T0 means initially what they have taken. T final means after the reaction what will remain or what will be the amount of product formed, right? So here you can see beta, initially imagine they gave me, I am having here 5 moles of N2 and here they gave me, I am having here 17 mole of H2 and here 0 moles. Initially they gave me, I have 5 mole N2, I have 17 mole H2 and I have 2 moles of ammonia. Now they gave me 2 reactants, they gave me their initial amount. So this question belongs to the limiting reactant because they gave me two reactants, right? Yes beta. Now if you go by the long method, how to check which is limiting reactant? So our first topic is which is limiting reactant and then we have to proceed. Our first topic is now, our first point is to find which one is limiting reactant here. We will see the shortcut also, but first of all let us see the concept. What is the concept, right? You can see here clearly that 1 mole N2 need how many mole H2? 1 mole N2 need 3 mole H2, right? If I take its image in I took its 5 mole, 1 need 3, 5 need how many? 15, huh? 5 need 15. So when its 5 will finish, its 15 will finish. But how many given here? They gave me here 17 moles. They gave me 17. Clear, bacha? That's why this will finish, this will remain. This will, if I write beta, I am writing the little obvious method to explain. Then we will come to shortcut also, okay? So here, final time. When 5 will finish, it's how much will finish? Out of 17, only 15 will finish. 1 finish 3, 5 finish 15. Still, how many moles remaining? Still 2 moles remaining. So it becomes 0. It's how many moles remaining? 2 moles remaining. So you can see which one is finishing first. Yes, N2 is the limiting reactant. Yes, beta? Is it right, Yamini? We will discuss shortcut also, don't worry. We will discuss shortcut, how to decide. So now we can see who is the limiting reactant? N2. So N2 will decide the product amount. You can see beta, 1 produce 2. 1 produce 2. So beta 5 finished, it produce how many? 10 moles. 5 will produce how many? 10. So it is the right answer. So 2 moles of H2 remains excess, whereas 10 moles of ammonia is formed. N2 was the limiting reactant, so it is finished and become how much? It is 0 now. Fine, bacha? Clear? Now we'll move to shortcut. How to find who is limiting with the shortcut, right? Same question I'm writing here. Same question I'm writing. Look at this. I'm writing same thing. N2 here, 3H2 here, 2 ammonia. Right? Okay. Yes, sir. Devik, right answer, beta. Right answer only. So, at time 0, what they gave us? In the equation, they gave me 5 moles of N2. They gave me 3 moles H2 and 0 mole of ammonia. So how to decide who is the limiting reactant, right? First our task is this one. Let us see. Before starting the question, we had to use shortcut, right? How we can decide who is the limiting reactant? What to do? We have to do this thing. Given moles, do one thing. Given moles divided by stoichiometric coefficient. whatever is the given moles, divide the given mole by the stoichiometric coefficient, right? Okay, bacha. If you see carefully, sorry. In this question, I was giving same. I'm giving same one. I am giving the same question actually, just to show you. I am giving the same question, right? I'm not giving other question. It is same. I'm just explaining same question. Okay, I'll give different question later on. Don't worry. How to decide? Given moles how many? Given moles are how many? 5. Stoichiometric quotient how much? 1. 5 by 1. Given moles how many? 17. Stoichiometric quotient how much? 3. You have to divide the given moles by stoichiometric coefficient. So here by dividing, what is coming? 5 by 1, and here coming by 17 by 3 means something coming 5.6 something, right? So which number is coming less number? Which is coming less? This number is coming less, right? Small number, short number. So whatever is getting the less number is the limiting reactant. How to find which one is limiting reactant? Instead of thinking this way, you can use shortcut. Divide the given mole of that compound, divide by its what? Stoichiometric coefficient. And out of all the reactant, which one is getting the least ratio? Here, the least ratio give us what? Limiting reactant. So from here, now I know which one is limiting. Now here I know very clearly that who is limiting. This is limiting. This is limiting now. And I know limiting will finish. Limiting will always finish from given to 0. So limiting become 0. 5 becomes 0. 1 finish 3. 5 finish how much? 15. So 15 will finish beta. How much will remain? 2 mole will remain. Right? 1 makes 2. So 5 makes how much? 10. So I solved the above question in same way. Like some different, using the shortcut only, right? I'm solving the same question but using little shortcut. Got the point? I'm giving you some more questions, you will understand it better way. Okay? Okay, bacha? Fine? Okay, now look at this. I'm giving you one more question on this basis. Is it done? Clear? Fine. Okay, I'm giving you one more question. So please solve it carefully. Imagine this time our reactants are A and B and C. And writing the coefficient, imagine beta, the coefficient here, coefficient is 3. Imagine here 2. And here 1. And making product. Imagine product is D. A, B, C, D are A, B, C, D. These are just reactant products. Now, at time 0, what they gave us? They're telling us that we are having it 15 moles. I'm having its 15 moles. I'm having its 11 moles. And I'm having its 4 moles, right? It's 0 moles. So please tell me the final amount of all of these. First decide which one is the limiting reactant and then proceed. Out of the given 3 reactant, which one is the limiting reactant? Use shortcut. Given mole by the stoichiometric coefficient. They gave me 3 reactants in this question. So first of all, find the limiting reactant beta. Yes, everyone. First decide the limiting reactant. First find the limiting reactant. Out of A, or B or C? Which one is the limiting reactant? Harshita giving right answer. Monica, Chetan. Okay. Right. Hbra shaking. Check it once again. Okay, fine. Let us see how to decide. Okay, everyone saying C is the limiting reactant. How to decide? Okay. Look, bache. Given moles. Given moles are how many? 15. Divided by stoichiometry. How much? 3. Given moles 11 divided by 2. Given moles 4 divided by 1. 15 by 3 is giving me with how much? 15 by 3 giving me how much? Almost 5. Here how much coming? 11 by 2. Giving us how much? 5.5. And here the clearly coming how much? 4. So which one is the smallest beta? Which one is smallest one? This is smallest number, right? Least number. This will tell us that okay, it is our limiting reactant. After doing this, we will get which is our limiting reactant. Now its work is done. We have used our shortcut to find the limiting reactant, right? Done. The next part is come to the main question. Now I can see its 1 mole will produce how many moles? 4 moles. Limiting that becomes 0, na? Limiting reactant will finish. Yes, beta. So 4 mole finished, 4 to 0. It was 4, now becomes 0. Initially 4 moles, now how many moles only? 0 moles. Okay. So 1 mole produce 4 mole. So 4 mole would produce how many mole? 16 moles. Very good. Right? You can see clearly. How many mole finishing? 4. 1 finish produce 4. 4 finish produce how much? 16. Right? Here we can see 1 mole finish how many mole? 2 mole. So 4 mole finish of C will finish how many moles? 8 moles gone. So how many moles remaining here? 3 moles excess remaining. Is beta? 3 moles excess remaining. Fine. Good. I'm saying once again, 1 mole finish 2 mole. So 4 mole will finish how many? 8. Out of 11, 8 finish. How many moles remaining? 3. 1 finish, 1 mole of C finish, 3 mole of A. So 4 mole will finish how many? 12. So how much remaining, beta? How much remaining? 3 moles of A. So 3 moles of A will be excess, will left. And similarly 3 moles of B will left. C will finish completely because it is limiting reactant and it produces 16 mole of D. Yes, beta. I hope we are clear now. I hope we are clear. Right? Okay, fine. 12 of A is finished, right? 12 of A is finished. So how many remaining? Remember, in the question they will ask how many moles of ABC remaining. 4 finished, 0. 11, 8 finished, 3 remaining. 15, 12 finished, 3 remaining. They will ask in the question how many remaining. In the end of reaction, how many moles will remain? Yes, beta. I hope you are clear now. Done? Fine. Okay. One more easy question I'm giving. Please try this. Try. Okay, fine, bacha. Look at this now. Easy question again. CH4 O2 giving CO2 to H2O. Stoichiometry you can see by balance equation. Here I am giving, we are having 10 moles of methane and 10 moles of O2. Tell me the final mole of methane, O2, CO2, H2O. Yes, everyone? Initial 10 moles of both are given. So finally tell me which will finish to 0, which will remain excess, and how many mole of reactant and product will be remaining or formed that way. Who is limiting? Tell me. Is everyone? Yes, beta. Who is limiting? Who is limiting? Let us see. First, our task is to decide the who is limiting reactant. Given moles 10 moles divided by coefficient how much? 1. 10 by 1. Given moles 10, coefficient 2. As you can see, it is small number, least number. So we got the idea that this is limiting reactant. O2 is limiting, right? O2 is limiting. We got the idea. Okay. Now limiting become how much? 0. Limiting to become 0. So now you see beta, 2 makes how much? 1. Here how much finished? 10 finished, na? 10 finished. 2 produce 1. 10 produce how much? 5. Right? 2 produce 2. So how much? 10 makes 10. Fine? Are you clear? Now we can see beta. 2 makes 2 needs how much? 1. 2 consume 1. 10 consume how much? 5. So how much remaining? 5 mole excess remaining. Here 5 mole excess remaining. Okay. Yes, Monica, Yamini gave right answer. Okay. Yes. Beta, 1 or 2 student is talking about cutoffs and all these things. Okay, beta, first of all, let us focus on the class, right? These topics are very important. Whenever you will join your offline classes, these things will help you. You will get an edge over the students. If you are clear about these topics, so you will be very good in the remaining topics also, okay? So focus in the class mainly. Great. Now, up to now, in the questions, I am giving you always moles directly. Now, in the question of limiting reactant, by chance, they can give you, maybe they give you weight, they give you volume. So from that also, you can convert them into moles. And then you can check the limiting reactant topic, okay? I am giving one question on this basis. Yes, beta. Let us see then. One different question now, okay? Imagine they are giving this one. Again, we are having N2 here, 3 of H2, 2 of ammonia. Now, at the time 0 beta, what they gave you, imagine, they are giving us, we are having here 56 gram, and here they're giving how much? 10 gram. 0. Now they are saying you have to find the final situation. What is the final situation? What will left excess, and how much mole of ammonia will form, and how much mole of ammonia will form, right? Clear, bacha? If they give you weight, sometimes we can solve the question directly in weight also, but it is better to find the moles First find the moles, then decide who is the limiting reactant, and similar to like in the last question we did, right? First of all, find the moles. Are they giving us the mole or weight? They give us mole. Sorry, they give us weight. So first of all, find the moles better. First find the moles. How many moles are given here? Tell me. See carefully. 56 given. So 56 beta, 56. If I find how many moles of N2 are there, 56 by 28, how many moles coming? 2 moles coming. So actually here they gave me 2 moles of N2. Here they gave us, we are having 2 moles of N2. Fine. And how many mole of H2 beta? How many mole of H2? I want to find mole of H2. How many moles given? 10 divided by 2. How much given? 5. 10 divided by 5, right? Yes. Now I have mole of both. So I can write here, I have 2 mole N2 and I have 5 mole H2. Now decide who is the limiting reactant. How we decide beta? How we can decide who is the limiting reactant? Yes? Tell me how we decide. We will take the given mole divided by coefficient 2 by 1 and here 5 by 3, right? So which number is small? This is small number, right? This is least. So this is telling me that it is our limiting reactant. So H2 is our limiting reactant. Yes, and N2 is excess. Are we clear here? First of all, convert weight into moles. Or by chance they gave weight here, they gave volume here. So get the moles first of all. After getting moles, then decide who is the limiting reactant. Fine. So here you can see it is the limiting reactant, and limiting become how much? 0 in the end. So we know that limiting though becomes 0 in the end. Fine. Now you see beta, you can see 3 mole produce 2 mole. 3 mole produce 2 mole. It was 0 here. So 1 produce how much? 2 by 3. So 5 produce how much? 2 by 3 into 5. So what is coming finally? 10 by 3 mole of ammonia will produce. 10 by 3 moles of ammonia will be produced. Okay, fine. Now similarly here you can see 3 moles consume how much moles? 1 mole. So 3 moles consume 1 mole. So 5 mole consume how many? 3 consume 1. 1 consume how much? 1 by 3. 5 consume how much? 5 by 3. So how much remaining? Out of 2, 5 by 3 moles are gone. So how much remaining? 2 minus 5 by 3. 2 minus 5 by 3 excess. Limiting the become 0. And the ammonia how much? 10 by 3. My main concern is to check or convert first weight into moles and then apply shortcut to get the limiting reactant. I hope we are clear here. I hope we are clear. Right? I am giving you the same one more question. Yes, well, look at this. Let us see. We are having here H2O2 is giving H2. First balance it. Let me help you to balance. This is a balanced equation, right? This time give me answer right. In previous question many students made a mistake. Carefully give the right answer. At time 0 beta, imagine they are giving me here I am having its telegram. We are having its telegram. Right? And here we are having its 320 gram. This is 0. So please find, by the same concept, find. First of all, convert weight into moles, then decide who is the limiting reactant, and then same concept. How many moles of product will form? Is everyone fast? Yes, we're done. Fast. Yes, but let us get the moles. How many moles are there? How we get the moles? Look, I want to get the moles of H2. How many? 10 divided by 2. 5 moles of H2. How many moles of O2 beta? We have how many moles of O2? 320 gram divided by how much? 32. How many moles coming? 10 moles, right? So I can say clearly from here, at time 0, they gave me 5 mole of H2 and they gave me 10 mole of O2, right? Who is the limiting reactant? Yes, beta, Monica. Shakeen, tell me, beta. Which one is the limiting reactant? Tell me. Which one is the limiting reactant? Fast. Who is the limiting? Yamini saying H2. Yamini saying H2 is limiting. Chandra saying H2. Shakeen, H2. Fine. How we decide? We look better. 5 moles given. 5 divided by how much? Coefficient 2. 10 divided by coefficient 1. Yes, it is small number. Least number. It will tell us that yes, it is our limiting reactant, right? So here we can see it is limiting. Now we know that limiting to become 0 in the end. We know very well that limiting to become what? 0 in the end. Yes, beta, become 0. So here you can see 2 moles consume 1 mole. So 5 mole will consume how much only? 2.5. 2 consume 1, 5 consume 2.5. How much remaining? 7.5 mole still remaining. 7.5 mole still remaining. 2 produce 2. So 5 produce how much? 5 mole. 5 produce 5 mole, right? That's it. This is how you can solve the question of limiting reactant. Now we can see the volume question also. Yes, Mr. Shakeen, right answer. Okay, now we will see some question of volume also. Volume question are very easy. Volume question are more easy than weight questions because volume question can be done directly without converting them into moles. Why? I will tell you. Why? I will tell you better. But as I said, some students are discussing about the cutoffs and all these things. Wait for this. 1 or 2 students, this Mohit beta, wait for the cutoff. First of all, attend the class carefully. Otherwise, the same result will come next year. Right? Whatever is going on, focus on that part first of all. Right? Okay. Let's see the beta. Now, the next thing is same easy question I'm taking. N2 here, S2 beta, 3 S2 and giving 2 ammonia. Remember, the molar ratio and volume ratio are same. So there is no need to make volume into moles to get the limiting reactant. You can solve the volume question directly because volume ratio of gases will be same as molar ratio. What I am trying to say, understand it carefully. What I am saying, stoichiometry is telling us that 1 mole N2 is reacting with 3 mole H2 and produce 2 mole ammonia, right? We know stoichiometry. Now, if I go volume wise, it was mole. If I say this is the stoichiometry in terms of mole, right? If you write stoichiometry in terms of volume, you see what is coming? 1 mole means how much volume? This much volume, this much volume, this much volume. So you will say same thing will come, na? You can say 1 liter consume 3 liter and make how much? 2 liter. So the molar ratio and the volume ratio comes same. So questions of volume, if they give all the volume in the question, you can solve it very easily without converting them into moles. Right? I am giving you one question. It will be easy to understand, right? Imagine this is a question given to us. Same concept we will apply. Imagine at time 0 beta, they gave me, we have 10 moles of N2, sorry, I am saying at initial, I have 10 liter N2 I have 10 liter H2 and I have 0 liter ammonia. In the question they're asking me, finally find beta how much liter N2 left, how much H2 and how much of ammonia. This they're asking. Now there is no need to make volume into moles. Directly you can solve the question. Why I am doing this? In case of weight questions, we converted weight into moles. But here there is no need. Why? Tell me. Because volume ratio and mole ratio will be same only. Clear, bache? So you can apply the shortcut directly here. If I want to find who is the limiting reactant, how will I find? First of all, we have to find who is the limiting reactant. How? 10 divided by beta, what is 1? 10 divided by 3, right? And here nothing else, right? 10 by 1, 10 by 3. So which one is the limiting reactant? Tell me fast. Hey bacha, which one is limiting? 10 by 1, 10 by 3. Small number coming. That's why this is our limiting reactant. This is our limiting reactant, right? Clear? Okay. H2 is coming limiting. Yes, everyone. S2 coming, S2 coming. 3 liter. Give me it's how much? 2 liter. So beta, you see, 3 give me 2. 1 give me how much? 2 by 3. And 10 give me how much? Into 2. So finally, we get 20 by 3 liter of what? Ammonia. Finally, we got 20 by 3 liter of ammonia. Right? So our main concern is, if question comes in volume, and they're asking finally volume, so there is no need to make volume into moles. It will waste your time only. So directly you can solve the question. Okay? You can apply the same shortcut, given volume by stoichiometric coefficient, to find the limiting reactant and then solve it that way. Okay everyone? I will take some more questions in tomorrow class on this basis, so that we can clarify it more. Okay? Then bacha, okay, this is it for today. We will see the remaining part of this topic tomorrow. Tomorrow also we will deal with the same topic, stoichiometric calculations. Okay bacha, bye then, see you.